going to show you guys what is a hyperbola. So we've spoken about ellipses, we've spoken about circles, and we've spoken about parabolas, but we have not spoken about hyperbolas. You'll see that a lot of the language is the same, but it is a lot different than the other ones. So what is a hyperbola? If I were to take a piece of paper or a plane and cut a cone with that plane, I would get this weird shape. If it's not through the center, if it's completely vertical and it is not through the center, then it is going to be this weird shape here. And it'll look, if I look at that cone, if I look at that plane, it'll look something like this, where they are exactly symmetrical, or it'll look like this, where it is exactly symmetrical. So let's talk language. But we're going to talk definition first. So a hyperbola is the set of all points in a plane such that the absolute value of the differences of the distances from the foci are constant. That is so confusing. So we're going to talk about what that means. Once we talk about what that means, it is going to make a lot more sense. But first we need to know what language is. So this is a hyperbola. It's a horizontal hyperbola because it goes right and left. So that's how I know it's horizontal. It would be vertical if it looked like that. So let's talk about what all of these things are. This is, let's use a different color here. This is the center. The center of the hyperbola is not actually on or in the hyperbola. It is in between them. It is the center of, you see these little vertices here? Like a vertex of a parabola. It is in between the vertex. Now these, exactly what they are, like a parabola, it is the vertex and the vertex, so they are called the vertices. So let me write this down. Center. And this is called the vertices. Okay? Now, just like an ellipse, the distance from here to here, from the center to a vertex, is A. So, A is the distance from the center to the vertex. And again, just like an ellipse, B is going to be the distance from the center to the co-vertex or co-vertices. So co-vertices are going to be in the opposite direction. And so the distance, let me use a different color for that. Let's see. What color do I want to use? Let's do orange. So let's say this to here is going to be B. Okay? And what this is going to make is a box. And we're going to talk about the box in a second. But first, I just want to go over all of the different vocab words. And then, again, just like an ellipse, we have the focus and a focus. Now, in an ellipse, when we had an ellipse, the center was in the middle and the foci were inside of the ellipse. Here, it is on the inside of the parabola, just like when we had parabolas, right? Our parabola, our focus was on the inside. Same thing. Our focus is going to be on the inside of the hyperbola. Okay? So on the outer skirts, but on the inside, just like a parabola. Okay? So that is my focus. So let's talk about what the definition is now that we know all the words. So this is a hyperbola on my cool little GeoGebra application. I don't really know what it's called. But this is a hyperbola. So I talked to you about a little bit about that box right here. And if I move my A and my B value, it moves the hyperbola. And if I were to move my H and my K, it would move my center, just like every other one, where HK is your key point, right? HK. So we have A and B. Now, the definition of a hyperbola is any point on the hyperbola, here or here, right, is the distance from the focus, from one focus to the point, and the distance from another focus to the point. You see L1 and G. This should say L2. But L1 and G, all right? The difference between these two points, or these two lengths, is always going to stay constant. So here it's 9.64 and 4.84. The absolute value of the difference of the distance to the foci. Again, it's a lot of words, but just know that the distance from that point, any point, x, y, to one focus and to the other focus, the difference of those lines is always going to remain constant. So notice how as I move it, the difference is not changing. That 4.8 right here is not moving anywhere. Nothing is happening to it. And just to show you that I didn't just put 4.8 there, if I move this, it doesn't change. But if I move this, 7.8, it moves. If I move this, it's not going to move. But if I move my A value, it is going to move. It is always going to equal, the difference of these will always equal double your A value. So that's 2A, right? So 3.9 times 2 is 7.8. That's why my B value moving is not going to change it. But my difference, so let's do like an easy number here. If I move this to, it's hard to get this exact, but about 4 and about 9, right? So about 8.59. 8.6 minus 4 is 4.6. Okay? So the point is that the difference between these will always remain the same. That is the definition. So let's reread the definition now. It should make a little bit more sense. A hyperbola is the set of all points. Remember we spoke about how the set of all points is always going to be in the definition. Is the set of all points in a plane such that the absolute value of the differences of the distances from the foci is constant. Again, so the difference between this right here and this right here is always going to be the same number. Okay. Every hyperbola has two axes of symmetry, which are, I'm going to erase this now because it's a lot to be on one diagram. So I hope you're taking notes. So two axes of symmetry, and that is going to be here and here. It is always going to be vertical and horizontal, and my axes of symmetry are called the transverse axis and the conjugate axis. So the transverse axis is always going to go through the actual hyperbola. So you notice how it crosses through. So I'm going to rewrite this here. And it goes through the hyperbola. Versus my conjugate does not. It is completely perpendicular. It does not go through the hyperbola. Not through. Okay, again, I hope you're taking notes. These axes are perpendicular to the center, right? So perpendicular, geometry terms, it is perpendicular, so they form a right angle. One is vertical, one is horizontal. The foci of the hyperbola always lie on the transverse axis. So we spoke about how they're on the inside of the parabola. They always lie on the inside and on the transverse axis. And the vertices are the endpoints of the transverse axis. So again, transverse axis, there are my vertices. And my co-vertices are endpoints on my conjugate axis. So those are my co-vertices. Distance again here is B. Distance here is A. And as the hyperbola recedes from the center, both halves approach asymptotes. So let's talk asymptotes. These dotted lines right here are called asymptotes, which we've learned in different sections are basically lines that the function will infinitely approach, but will never, ever, ever touch. And that's really important with this because it's never, ever going to cross this line. It's not going to go like that or like that. It is never going to cross this line. So that is going to help us draw our hyperbolas. Okay, so here are the two diagrams. Here's a horizontal hyperbola and a vertical hyperbola. There's this box here, right? And I told you we were going to talk about some box. Now this box here is basically the key of how we are going to graph our hyperbola. Because the distance from the center, let's make this a little thicker. The distance from the center to the vertex is the vertex, all the vertices are on the edge of the box. So right here, this distance right here is A. And then this distance right here is B. And that's really important because in our equation, we have A and B in it. Now, what do you think from what we know about ellipses, what is the distance from, and it's already on here, so you're cheating, but it's okay. The distance from the center to one of the foci, to a focus, is going to be C. So again, A is from the center. Let me make this thinner. A is from the center to the vertex. B is from the center, everything's from the center, to the co-vertex. And C is from the center to the focus. Again, these are the exact same thing, same as ellipses. Okay, so same thing goes here. From here to the vertex, it's A. A. From here to a co-vertex, it is B. And from here, and then the focus would be somewhere here, would be C. Okay, and it goes the same direction. So this is also A, technically. Right? This is also C, technically. And then this is also B, technically. So it goes in all directions. So this is really important, A, B, and C. Now, how do we get A, B, and C? So when we were talking about ellipses, it was A squared minus B squared equals C squared. Right? But as you know, notice here, it's a little bit different because the C is the longest one, right? So our C is actually going to be our hypotenuse. So it's A squared plus B squared equals C squared. It is the exact same thing as Pythagorean theorem. So A squared plus B squared is equal to C squared. So let's talk about orientation and how they look different for a standard form. So let's zoom out a little bit. So orientation, so this one is horizontal, again, because it goes right and left. So it is horizontal. Meaning that my leading, so again, we're going to use the same patterns as ellipses, meaning our leading variable is x, and A is correlated directly with x. because it is going horizontally, meaning B is directed immediately and directly with B. So the way I'm going to write this is, so we have our x minus h, again, squared, and we have our y minus k squared. But here with ellipses, the reason that this is different is that this is a minus here. It is no longer a plus. It still equals 1, but we have a squared here, and we have b squared here. Again, it's really important to note here, x is with a because a and x are here, and y is with b because b and y. So because b is vertical, b is underneath y. But the key with ellipses here is that a, I wrote it over here, a is always first. Okay? The reason that this is important is because it's subtraction. Subtraction is not the same either way. So like 1 minus 2 is not equal to 2 minus 1. So it's really important that we line up our variables, not x and y. It always has to be a first and then b first. So the way that this is going to be different for a vertical, wrong color. For a vertical, meaning it goes down and up, right? So the reason that this is going to look different, the way it's going to look different, is that, so we're going to have, it's going to be minus because it's a hyperbola, but it's still going to be a squared and b squared. But because here a is vertical, so that means that my y is going first. And then my x goes second. That is how these are different. So here we have a is directly affiliated or directly affecting your y because it is vertical, and your b is directly affecting your x. So therefore, I have b here, which is with x, and I have a here, which is affecting y. So it's really important to notice these patterns because it's important that with my vertical, y is first. Because remember, vertical is y and horizontal is x. So my vertical, y is first. My horizontal, x is first. So what, by the way, with ellipses, the cones, with ellipses, a was always bigger. That is not the case, okay? A can be bigger than B and A can be less than B. It does not matter, which I can show you it here on this diagram. A can be tiny and B can be really big, or B can be tiny, A can be really big. It didn't make a difference. It's still a horizontal ellipse. Horizontal hyperbola. All right, foci. So the foci are always going in the same direction as A. So if that means, let's do vertices first actually. So A, I'm going to do it in blue because vertices are my A, right? That is what is directly affecting my vertex or vertices. So for my horizontal hyperbola, A is directly affecting X. So that means that my center, right? I don't have that here, but my center is HK. So that means that if it's directly affecting X, that means Y is not changing. So that's going to be a K. And so therefore, this is going to be H plus or minus A, whatever A is. So if A is 2, it's going to be H plus 2 and H minus 2. So that's going to help you find your vertices without actually having to graph it, because sometimes graphing it is harder than actually doing the math. Okay, so then we have the vertices of a vertical hyperbola, and that's going to be, instead, A is affecting Y, so my X is not changing, but my Y is now going to be Y plus or minus A. So it's really important to identify when you're given your standard form what this A or B is directly affecting. So my co-vertices are going to be the complete opposite. So H is not changing here. But K is going to change, and it's going to be plus or minus B. And then same thing here. H is now changing, and oh, this, I put Y here. This should be K. And this K is not changing, so it's going to be plus or minus B. So again, so this is B. Our foci are being directly affected by C, so it's going to be foci and vertices are on the same line. They are both on the transverse axis. So if A is X, that means C is also X. ... C is also X. So that's really important for here. A is Y, so that means that C is also Y. So that means that here I can follow the same pattern. H and K are staying the same, and it's going to be plus or minus C. And here it's going to be H and then K plus or minus C. So sometimes it's easy to graph it, sometimes it's easy to just do the math. And then equations of the asymptotes. So notice the asymptotes are lines, right? And so it's going to follow y equals mx plus b. But we don't know what mx plus b is. But we can figure out what m is, right? Because the way that this box works, so when I have this box, my asymptotes, here's my center, my asymptotes go from corner to corner, right? So that means that if I want to find the slope between this point and this point, I can go up, rise, over, run, which is A over B, or B over A, depending on which hyperbola we're talking about. So for this one, for a horizontal hyperbola, it is going to be rise over run is B over A. So for this, it's going to be y equals plus or minus, because we have plus and minus, plus or minus B over A, and then the rest of it is just like vertex form. X minus H plus K. And then we have the next one, which is the same concept, except here it's going to be A, this is A over B. So it's y equals A over B, or plus or minus A over B, X minus H plus K, and then you would just expand it. Here, I'll do this in colors because I've been consistent. Why stop now? And again, remember HK, I'll write it somewhere. I'll write it here. HK is the center. All right, so in the next video, I'm going to go over some sample problems.